The binomial probability model is a bit different. First of all, there's a fixed number of trials. All right, so we'll call that n trials. So the probability of success is the same each time. We call that P, probability of success. The probability of failure is 1 minus P. We also call that Q. And then we have we have X number of successes. Successes. All right, and then we also have n minus x number of failures. There's a couple of different ways to calculate binomial probability, and one of them is using a formula, and you might have seen a formula something like the following, which is the probability of x successes is equal to NCX, and choose x. We have P to the x and Q to the n minus x. All right, well, let me show you a little bit about what that is, and then I'll show you how to use StatCrunch to calculate this. All right, so the idea is, well, let's say that we do some sort of gender sorting thing where it's going to be more probable to have a boy than not have a boy. And each time, here's our first kid, here's the second kid, and for some reason, these parents, they want a boy. All right, well, let's say the probability of a boy, instead of just doing 1/2, we'll say the probability of having a boy this time was 2/3. They have a 66% probability of having a boy, and therefore 1/3 probability of not having a boy. All right, same thing for the second kid. They do the same gender sorting medicine or treatment where they actually have more probability of having a boy than not having a boy. All right, so probability of 2 boys is 2/3 times 2/3, or 4/9. Probability having a boy than not a boy, that's 2/3 times 1/3, or 2/9. Probability of having not a boy and then a boy, we have 1/3 times 2/3, or 2/9. And then we have the probability of 2 not boys, which is 1/3 times 1/3, or 1/9. And if you notice, we have 4 plus 2 is 6 plus 2 is 8 plus 1 is 9. So we have 9/9, or a probability of 1 to either have 2 boys, a boy and then a girl then a boy, or girl, girl. All right, and we were calling these not boy, not boy. All right, so when you think about this, if I said, what's the probability of having 1 boy? In other words, 1B out of 2. All right, and so I could look on this probability tree, and I could say, well, you could have 1 boy 2 ways. One way is boy, then not boy. Another way is not boy, then boy. All right, so during this one, we have a 2/9 probability, and this one we have a, well, guess what, a 2/9 probability. It's either or, either your boy is the oldest or the boy is the youngest, so either or, we're going to add those together. In fact, this is 2/9 plus 2/9, or 4/9. Okay, so how does that relate to this formula? And again, I already know the answer. The answer is 4/9. That's the probability of having 1 boy out of 2. And again, order doesn't matter. It could be the older boy or the younger boy. But here's the idea. Well, n choose 2, that's 2 kids, 1 boy, right? X is sort of the success. X is having a boy. All right, so 2 choose 1. That's 2 ways that this can happen. All right, and then we have the probability of having a boy. That was 2/3 to the number of times that you have, in other words, a success, in this case having a boy, which is 1. Probability of not having a boy. That's 1/3. N, number of trials, 2 kids, minus x, so 2 minus 1. So this is 2 times 2/3 times 1/3, both to the first power, right? All right, so this is 2 times 2/9, or 4/9. Okay, so this is probability of having a boy to the number of boys, probability of having not a boy to the number of not boys, and there are 2 ways that this happens. We can see that with this probability tree, all right, but the formula does it even a little bit, does it for, well, we could have 10 kids now, and I don't have to do, you know, the probability tree for 10 kids would get completely out of control, but I could have, okay, how many ways are there to have 2 boys out of 10 kids? All right, so if I were to have 2 boys out of 10 kids, well, now I would have, let's see, 10 choose 2. I have 2/3 to the 2 boys, and then 1/3 to the 8 not boys. All right, and I could figure that out on my calculator and tell you the probability of that. But instead, I'm going to use StatCrunch and show you how to do it on StatCrunch. So open up StatCrunch from the My Math Lab menu or My Stat Lab menu. And if you click on Stat, Calculators, and then Binomial, it opens up this binomial calculator. All right, so we're going to start out with 2 kids. We said a 0.66, actually I'll round it to 0.67 probability of having a boy. And we want to know the probability of having 1 boy. Well, here we go. We have, let's see, the probability of having 2 boys was 4/9. The probability of having 1 boy was 4/9, and the probability of having no boys was 1/9. All right, so we can see that from our probability tree, but now we can also see it in our binomial calculator, and we can see that this 0.442, by the way, that 4/9 it's rounded because I had to round the probability to 0.67. Now I'll go ahead and I'll write, okay, well let's do 10 kids. And I want to know the probability of having 2 boys from those 10 kids. Well, that's 0.0028, right? We have a much higher probability of having, you know, it looks like 7 out of the 10 boys be, 7 out of the 10 kids be boys. And that actually totally makes sense, because if we go back to our standard deviation and expected value, we have the expected value is the mean for, this is binomial probability distribution here, and in this case, if we have 10 kids, it's 10 times 0.67, or 6.7. The mean is 6.7, and we can see that that's our highest, that is our expected value, that's the highest probability of getting approximately 7 kids on our binomial calculator. All right, so we can compute this. We can have greater than or equal to 2, and it will calculate 2 and 3 and 4, 5, 6, 7, 8, 9, or 10 boys, and when it puts it in red, it's adding all of those probabilities. Just one last reminder, we have the expected value for, or the mean for binomial distribution, and we also have the standard deviation, which is the square root of NPQ. All right, in this case, it's the square root of 10 times 0.67 times 1 minus 0.67, or 0.33.